How's it going, everyone? This is a tutorial on how to calculate determinants. And this is a strategic game. There's many different ways to get the determinant of a matrix. So we're going to see what's the optimal way to do it. So let's get into it. Okay, in this case here, well, we know that we have a 0, right? So calculating the determinant using the row or column with a 0 is the easiest way to do it, but we can actually make it even easier because we can create another 0 right here using row operations. So let's do that. Okay, we're going to do row 2 minus 3 row 1. And adding or subtracting the multiple of a row does not change the determinant. So that's pretty convenient for us. Okay, 3 minus 3 is 0. 2 minus 6 is -4. And 2 minus 9 is -7. Okay, so now we have a column with 2 zeros, right? So that makes things much easier. Okay, so we're going to have a positive in front of that 1, so it's going to be positive 1 times the determinant of -4, -7, 9, and 8. Okay, so for a 2 by 2 matrix, we just have -4 times 8 minus 9 times -7. Okay, so that gives us -32 plus 63. Okay, so our final answer becomes 31. Okay, let's move on to the next one. Okay, so in this case, we don't have any zeros, but we can use row operations to create some. So first off, it's much easier if we have a 1 right here, right, to bring things to row echelon form. So let's do that. Let's switch row 2 and row 1. And if we do that, our determinant becomes negative, right? So we're going to add that negative sign to correct for that. So 1, 7, 8, 4, 3, 2, and 3, -9, 3. And then we're just going to do row 2 minus 4 row 1 and row 3 minus 3 row 1. And because we're just adding a multiple of a row, this does not change our determinant, so we just only have that negative sign in front. Okay, so we have 1, 7, 8. 4 minus 4 is 0. 3 minus 28 gives us -25. 2 minus 8 times 4, that's 2 minus 32, and that gives us -30. Then we have 3 minus 3 is 0. We have -9 minus 28. -9 minus 21, which is -30 again. And then we have 3 minus 24, which gives us -21. Okay, so now we can divide rows by some numbers to make things even easier, or we can just calculate the determinant right away because we have a 1 here and zeros everywhere else. But why not create some smaller numbers? So if we divide row 2 by 5 and row 3 by 3, so we're essentially multiplying by 1 over 5, which means our determinant becomes 1/5, right? So to compensate for that, we're going to multiply by 5. And dividing row 3 by 3, we're essentially multiplying by 1/3, which makes the determinant 1/3 smaller. So to compensate for that, we're going to multiply by 3. Okay, so we have 1, 7, 8. We have, so this we are dividing by 5, right? So we're going to have 0, -5, -6, and the bottom row divided by 3, so we have 0, -10, -7. So there's our -5, 3, and then we have that 1 multiplying the determinant of -5, -6, -10, -7. Now we can multiply both rows by -1, which is going to multiply our determinant by -1 twice, which essentially means the determinant doesn't change. So we can write this without the negatives as 5, 6, 10, and 7. That makes things a little easier. So we have -5 times 3, and then we have 5 times 7 minus 10 times 6. So we have 35 minus 60 in the brackets. So 35 minus 60 gives us -25. Okay? So then we have, that's going to be positive, right? Because we got two negatives. So we have 5 times 3 times 25. And that gives us 375 as our answer. Now let's move on to the next. Okay, so here we have a 4x4 matrix, and right away we see a 0, which could make things easier for us. But rather than going along this row or this column, I think it would be even easier to just start creating zeros to bring this closer to row echelon form. So let's do that. Okay, we're going to do row 2 minus row 1, row 3 minus 4, row 1, and row 4 minus row 1. And this does not change the value of our determinant because we're just adding a multiple of another row. So 1 minus 1 is 0. 3 minus 2 is 1. 2 minus 3 is -1, and 3 minus 2 again is 1. 4 minus 4 is 0. 1 minus 8 is -7. 5 minus 12 is -7 again. And 0 minus 8 is -8. Then we have 1 minus 1, 2 minus 2, 1 minus 3, and 2 minus 2. Okay, so what we then have is a row with almost zeros here. Great. So that 1 is going to be multiplied by this determinant here, and here we have a row of almost zeros. So that makes life a lot easier for us. We can jump straight into that determinant. Okay, so we have 1 multiplied by the determinant of 1, -1, 1, -7, -7, -8, 0, -2, 0. And this determinant we will calculate based on this row here. Okay, so the coefficient in front, okay, the positive or negative, I mean, right in front of that -2. So this is the third row and second column, right? So there's our 1 in front from before. Then we have our -1 to the power of 3 plus 2. Okay, so that's odd, right? So that's going to stay a -1. Then we have that -2 there, and then we have the determinant of the matrix we get when we cancel out the row and column of that -2, right? So we have the determinant of 1, 1, -7, -8. So let's simplify things a bit. So we have -1 times -2, so that's just going to be a 2, multiplied by 1 minus -8 minus -7 times 1, which is -7, right? So we have 2 times negative 8 plus 7, right? So that's 2 times negative 1, so that's just going to be a negative 2. All right, let's move on to the next. Okay, so let's calculate the determinant of this one. Again, I think it's easiest to just bring it to closer to row echelon form. Okay, so we're going to create some zeros right here. And all we're doing is just row 2 minus 2 row 1, row 3 minus 2 row 1. We're just adding a multiple of another row, so that's not going to change the value of our determinant. Okay, so we have 2 minus 2 is 0, 1 minus 4 is negative 3, 3 minus 2 is 1, 2 minus 2 is 0, 1 minus 4, again negative 3, 1 minus 2 is negative 1. Okay, so we have 1 times the determinant of negative 3, 1, negative 3, negative 1. So that is going to be negative 3 times negative 1 is 3 minus negative 3 times negative 1, so minus negative 3. Okay, so that's 3 plus 3, which gives us a 6. Well, let's go on to the next question. Okay, so with this one, we do have a 0 in the middle there, so expanding along second row or second column could be a quick way to do it. Doing row operations would also be pretty easy in this situation, but we've been doing that the whole time, so let's just expand along the second row here just to do something different. So first we have that 1 there, and that's going to be multiplied by negative 1 to the power of 2 plus 1, because it's second row, first column. And that's going to be multiplied by the determinant of the matrix we get by canceling out that row and column, right? So it's going to be 2, 1, 1, 1. Okay, plus 0, plus, then we have, I'm going to change colors here, then we have the other one right here. Okay, so again we have 1 times negative 1 to the power of 2 plus 3, right, because that's second row, third column, multiplied by the determinant we get if we take out that row and column, right? So we have 1, 2, and 2, 1. So let's simplify that. We have negative, right, because a negative 1 to the power of 3. And then we have this determinant, so 2 times 1 minus 1 times 1. Plus, that's also going to be a negative 1, because 2 plus 3 is 5, which is odd, times the determinant of 1 times 1 minus 2 times 2. And let's simplify that. So we have negative 1 minus negative 3, which turns into negative 1 plus 3, which is 2. All right, let's go on to the next one. Okay, so we've got a 4 by 4 matrix, and we want to find the easiest row or column. Now it's tempting to look at this one and say, oh, 2 zeros, some ones, that is easy. But the easiest is actually this one right here, because it has 3 zeros. So that is the one we are going to go with. Okay, so everything's going to be 0 except for what that 2 multiplies. So we're going to have 2 times negative 1 to the power of 3 plus 4, right, because we have our third row and fourth column. Okay, that's going to turn out to be a negative 1. Multiplied by the determinant of what we get when we take out this row and this column. Okay, so the matrix we end up getting is 1, 0, 0, how convenient, 2, 1, 1, and 2, 1, 3. Okay, now how do we get that determinant? Well, easiest to go along this row right here, because we have these zeros, which will make life so much easier, right? So we have, okay, that's 2 times -1, that's just a -2, multiplied by 1 times the determinant of 1, 1, 1, 3, right? Because that's what we get when we cancel out the row and the column of that 1 there. So we have -2 times 3 minus 1, which gives us -2 times 2, which is -4. So that 4 by 4 matrix is not as intimidating as it seems. All right, let's go on to the next. Okay, here we have a 2 by 2 matrix. And, well, we could do it the long and formal way and just say, okay, so that's 1 times 2 minus 0 times -34. But that 0 quickly shows us that we're not subtracting anything, right? We're just subtracting 0. So that's just going to give us 1 times 2, which is 2. That's a quick and easy one. Let's go on to the next. Okay, so here you might be tempted to say, oh look, there's a row of zeros, there's a row of zeros, there's a row of zeros, and just pick one of those. But the situation is even easier because you've got a matrix that's already in row echelon form, which means the determinant is just going to be multiplying those diagonal values. So it's just 4 times -2 times 5. And that is going to give us -40. All right, let's go on to the next. Okay, so here once again, it's a 4 by 4 matrix, but it's already in row echelon form, which means the determinant is much easier of a calculation than it seems. We just multiply those diagonal values, and one of those values is a 1, which makes things even easier. So we just have 2 times -12, so we have -24. Okay, let's move on to the next. Okay, here we have matrix A and matrix B, and we want to know the determinant of B equals what constant times the determinant of A? Well, if we look at B closely, we'll actually notice that B equals A transpose, and the determinant of A transpose equals the determinant of A. And that follows from the fact that the determinant can be done along any row or any column. So what we actually have is that x equals 1, okay, because the determinant of A equals the determinant of B. Well, let's go on to the next. Okay, so very similar question, except B is different. B is equal to CD in the first row and AB in the second row. And we want to know, determinant of B equals what times the determinant of A? Well, what happened with B is we just switched 2 rows of A, and that makes the determinant negative. All right, so there we go. Determinant of B equals negative determinant of A. Let's go on to the next. Okay, here we have same kind of question, but B equals AB in the first row and A plus C, B plus D in the second row. So here you'll notice that the second row of B is just the second row of A plus the first row of A. And when we're adding a multiple of one row to another, that does not change the determinant. Okay, so determinant of A equals the determinant of B. And let's do another. Okay, so here B is equal to AB in the first row and 2C, 2D in the second row. So we're multiplying a row by a constant, which will make the determinant bigger by a factor of that constant. So the determinant of B will be twice as large as the determinant of A. And that is the answer to that one. So hopefully that makes you more comfortable with determinants, and enjoy that until next time. Bye-bye.